Hello everyone, welcome to Rasayan Academy, guys. And yes, we are going to continue in our short trick series, and there are a lot of things to talk about. Right, first thing first, today's topic of discussion is going to be your allenes, biphenyls, Spiro compounds, and alkylidene cycloalkanes. Now, for all of these systems, we are going to find out the RNS nomenclature, right? And this is going to be a short and descriptive video. Directly from this, you can solve your previous year questions from CSIR NET, GATE, and BARC exam, IIT JAM exam, right? So, yes, we are going to start learning the RNS nomenclature for the allenes, biphenyls, and spirocompounds and alkylidene cycloalkanes. So let's see these systems one by one. First of all, we are going to start with the allene, right? So yeah, let's see. So first of all, we have to understand that not all the allenes are chiral. The ones which are properly substituted, only those are chiral, and only those can be given the name of RNS, right? So first thing first, a properly substituted allene is chiral. So if we are looking at this kind of allene system, that is, it is having all the four groups are same on the allene, right? They could be hydrogen, they could be methyl or any other group. If all the four groups are same, the allene is going to possess a sigma plane like this. So this sigma plane is going to bisect the molecule into half, and another sigma plane is like this, which is then going to bisect the molecule into half. Okay, so this molecule will have plane of symmetry. It is achiral in nature. Similarly, you already know that allene system is having two perpendicular planes, right? So these two perpendicular planes are going to bisect the atoms in each other, right? Then you have the another type of a allene system in which on one carbon you are having two same groups. That is, on one carbon you are having two methyls, on the other carbon you are having two hydrogens. So once again, the plane which contains these four atoms, two carbons, two hydrogens, that plane is going to bisect in between these two methyl groups. Once again, there is a plane of symmetry and it is achiral. Now, about the last type of system, that is, if you are having two types of group on each carbon, then you cannot pass a sigma plane in the molecule, from whichever angle you are trying to visualize. So that is why this is going to be chiral. And if you are able to imagine, that is the best thing. What you have to do is, if you want to draw this molecule into Fisher projection, from where the RNS nomenclature is very easy, you can just imagine that you are standing, let's say, you are standing on this line. Okay, so if you imagine that you are standing on this line, you will see that you're going to see this molecule as a line. Okay, the bonds are going to be seen as a line, and the first thing that we see, we write it as a bold line. That's why I've written a bold line over here, because this is the first thing that I see from this side. So okay, so let's imagine that you are standing over here and you are looking at this carbon. So on your right hand side you are going to see this hydrogen, on your left hand side you are going to see the methyl. Okay, you can pause the video and check again. On the right hand side you will see the hydrogen, on the left hand side you are going to see the methyl group. And what about the hydrogen methyl over here? They are going to look straight. Okay, they are going to look like they are in a vertical line like this. So hydrogen is above, absolutely, methyl is below. Okay, so now how do you do the nomenclature? The very easy step is, you have to give priority based on the CIP rules, but remember that always give priority on the bold line first. That is, the methyl is going to have first priority and the second priority goes to hydrogen. So you're going to number first on the bold line that you see over here. So here, this side, you were able to see a horizontal line as the bold line. Okay? So 1 and 2, third is for the methyl. Okay, because now we see the thin line, first priority goes to methyl. So third is methyl. We are going to ignore the fourth priority group. Okay, we are not going to look at the fourth priority group over here as we did in the RS nomenclature of a asymmetric center. So 1, 2, 3, rotate. This is going to be clockwise. If you get a clockwise motion, that's R. If you get an anti-clockwise motion, then you get a S. So this is absolutely R. Now, if you want to confirm this, you can look at the molecule from the other side. Let's say you are visualizing the molecule from this side, but this side you see that there is a vertical line. Okay, you see that this hydrogen is on the top, the methyl is on the bottom. So you see a vertical bold line. The first thing that we see, that we write as a bold line. Hydrogen is on the top, methyl is on the bottom. Now this was easy. Moving onwards to the thin line, you see a horizontal line. Now when you are standing over here, for example, and visualizing, you will have the methyl on the right hand side like this, and you will have the hydrogen on the left hand side like this. Once again, give the priority 1, 2, 3, and this is clockwise once again, so it is R. Okay, so from both the sides you can check, it is going to be R only. You will get the same configuration for the same molecule from whichever side you want to see. Okay, so let's try this on the other alene system as you can have. Okay, so yeah, this is also the same system, so it's going to give you the R configuration, right? Let's try it on this molecule. So now if you see, all four different atoms you are going to have. So first of all, visualize once again, whichever side you feel is easier for you, visualize from that side. So let's say I'm visualizing from here. I see a horizontal line first. In that I see hydrogen, which is on my left hand side, COOH is on my right hand side, right? And the thin line, top there is methyl, bottom there is bromine. Okay, so this is what I see. Now give the priority order on the bold line first. 1 and 2. 3 goes to bromine. Fourth priority we ignore. So it is what? 1, 2, 3 anti-clockwise. It is going to be S. Now if you visualize from this side, then also, you know, if you want to visualize from the other side, then also you see that on the bold line, that is a vertical bold line, you see a methyl and a bromine like this. And if you visualize from this side, the hydrogen will be on the right hand side and the COOH is over here. Give the priority 1, 2, and 3. So what is it? 1, 2, 3 is once again anti-clockwise. Ignore the fourth priority group. It is still S. So the same molecule will have same configuration from whichever side you want to visualize. Okay. Now this is an accurate method and it hardly goes wrong. The same method we are going to apply to the biphenyls. So if you have noticed, the allenes, biphenyls, Spiro compounds, and alkylidenecycloalkanes, all of these are chiral because of a chiral axis, right? So they are chiral because of a chiral axis, and that is why we are going to now do the nomenclature. So yes, once again, about the biphenyls, not all biphenyls are going to be optical activity. Only heavily substituted biphenyls have restricted rotation. So they show optical activity. Now, when we are talking about heavily substituted biphenyls, why do we require heavy substituents? Because biphenyls or a simple biphenyl like this can undergo rotation like this. So if it undergoes rotation, it at room temperature it is not resolvable. What is resolvable? Resolvable means you cannot separate two enantiomers out of it. But let's say if we are providing a bulky group over here as well as another bulky group over here, so what will happen? These two are going to collide when, or let's say they are going to have a steric hindrance, and they are not able to rotate. They are stuck. So we want them to be stuck. We want them to basically have a restriction in rotation, and only that way you can have a resolvable biphenyl system or a chiral biphenyl system. This whole phenomenon of restricted rotation is also called as atrope isomerism. Okay, atrope isomerism. Okay, so yes, we move onwards and we see the RS nomenclature of this biphenyl system. So as you can understand what is written, one of the phenyl ring is planar, the other one is perpendicular like this. Okay, so this part is perpendicular, the COH has to be above. Now once again, just like your alene system, you have to visualize. Let's say you're visualizing from here. So this one ring is planar, the other is perpendicular. So this part must have been below. So the nitro is below. Just imagine the nitro is below, COH is above. So looking from here, you see a horizontal line first. Once again, you see a line like this, and the COH is going to be on your left hand side. Okay, and the nitro is going to be on the right hand side when you look from here. The thin line which comes after this one is going to be the COOH and the nitro below. So once again, you give the priority based on the CIP rule, but first give priority on the bold line. So on the bold line, you are having the nitro first priority, second priority to the acid, third priority on the thin line goes to nitro. What is it? It's going to be anti-clockwise S. You have to ignore the fourth priority group. It is that easy, guys. Okay, it's very, very simple. Now if you want to look from this side, that also you can do. You are going to see a bold vertical line where COH you have above, nitro you have below, and on the left hand side now you see the nitro, and on the right hand side you see the COH group. Give the priority 1 2 3. It is anti-clockwise once again S. So from both the sides, it's going to be the same. You just have to find from one side only. Trying this out on the other biphenyl system. Now you would be surprised that there is a hydrogen. This is not a bulky group, but only the sulfonic acid works over here, and this is your resolvable biphenyl system. That is, it will give you enantiomers, right? It is restricted in rotation. Okay. So yes, visualize from this side. So you see a horizontal line once again in the bold, and hydrogen on the right, SO3H sulfonic acid group on the left, sulfonic acid group once again on the top, and this is bottom on the thin line, right? So you can imagine, and first priority on the bold line 1 and 2, third priority over here. So what is it? 1 2 3 again anti-clockwise S configuration. Okay, so yes, this is how you name the biphenyl system. Similarly, sometimes what happens is to confuse you in the questions, sometimes there is RS nomenclature asked for this type of a biphenyl system. Let's say I still have a nitro over here, I have a COOH over here. This side there is below the plane nitro and above the plane COH, but I also have a methyl group over here, okay, on the meta position, and here also. So am I going to include the methyl in the RS nomenclature? Not at all. You are not at all going to worry about this. You are just going to visualize only these two groups which are responsible for the restricted rotation. Only that you're going to see, right? So visualize from here once again. You see nitro on the right, you see COOH on the left, this nitro on the top, this COH on the bottom. It will be the same system. You are not going to include the side substituents ortho or para. Okay, only these two ortho. So meta and para you're not going to consider, right? So 1 2 3, this is going to be R. Okay, now moving onwards to the spiromolecules. So spiromolecules once again are chiral due to a chiral axis. Okay, and this is a spiromolecule where, spiromolecules are of two type. One spiromolecule where you are actually having the substituents far away from these carbon, and this is also symmetric in nature, so you cannot just take it as a tetrahedral carbon system. However, See, this kind of spiro molecule will have some difference right from the atom from where it is connected. So this could be taken as a tetrahedral system. These are two different spiro compounds. This one and this one. These are two different spiro molecules. Okay. So first of all, you do the nomenclature of this kind of a spiro system. It could be this or it could be this as well. Okay. All right. It could be this as well. It will have the same configuration, guys. All right. And obviously this you need to be a six-membered ring. Sorry. This has to be a six-membered ring because then only you can have a carbon atom in the straight chiral line. Okay. So yeah, this is going to have the same symmetry. All right. We are considering the six-membered ring over here. Okay. Anyways, so I just mean to say these two are going to be the same, right? Now, what about the first one? What you're going to do is imagine from any one side and you are going to see it is the same as your alene system. The hydrogen is on the left, right, and COH is on the left. On the top you have COH and on the bottom you have a hydrogen. Okay, number on the board line first, 1, 2, 3, it is anti-clockwise S. Okay, the same goes for this. This is going to be 1, 2 and 3. You rotate it, it is going to be anti-clockwise S. So after practicing a lot of molecules, what will happen is just by looking at the molecule, you don't even have to take it into Fischer projection. Just by doing the rotation, you will be able to write it nicely because we are ignoring the fourth priority group, right? So only the rotation matters. But what happens to this type of spiro compound? Now, this is very important. So, different nomenclature system is followed as it is going to be considered as a asymmetric carbon. So, we are going to give the priority here, just like you have it on a chiral carbon having four different groups. So, how is this different? This is going to be different because you are going to consider these two rings as one ring as A, the other ring as B. Okay, so how is it going to be named? See, the ring A is going to have a oxygen, the one which is having greater priority goes 1. Ring B has the same atom, so this is second priority. Then you come back to ring A. This carbon will be third priority and this carbon will be fourth priority. All right. Now you do the rotation just like a symmetric carbon. 1, 2, 3 is clockwise. This is going to be R. Okay, so this chiral center is because of R. Now, you know, the previous spiro molecule, this was chiral because of a chiral axis once again. But this is also chiral because of a chiral axis, just that their configuration method is different because here on the first point of difference it is having two different types of atoms, and here on the first point of difference the carbon chain is going on and it is the same. It is different only at the 1, 2 and third point, so that is why you can't consider it as a tetrahedral carbon, right? Chalo, moving onwards, try out the same over here. Ring A and ring B, so you can randomly take ring A and B. It's not necessary that left one will be A or something. Now 1, 2, 3 and 4. Give the numbering 1, 2 and 3 anti-clockwise. This is S and this is the enantiomer of the ring written above. Okay. Now what about these? Once again, ring A, ring B, carbon first priority, second priority, this goes third priority, this goes fourth priority. So 1, 2, 3, this is going to be R as well. Okay, so these type of spiro compounds will be named like a symmetric carbon, and this one just like your alene system. Okay, so be careful which system you are doing the nomenclature. The last one is your alkylidenecycloalkanes. What is that? So this is your methylene, yeah, methylidene cycloalkane because you are having a C unit. just a carbon doubly bonded. And if you understand, if you write the molecular orbital diagram for this system, you will understand it is exactly the like that of an alene system, right? Because this carbon is, yeah, it is perpendicular to this carbon, because these substituents are planar, these are perpendicular. So once again, if it is similar to alene, you are just going to imagine, visualize over here. So on this side you see a vertical line, COOH is above, hydrogen is below, and who is on the right hand side? This hydrogen. This is your methyl on the left hand side. So give the priority 1, 2, 3, and let it be the fourth one we are ignoring. So 1, 2, 3 is clockwise, we get the R configuration for this system. Okay. Similarly, this is another, this is your methylidene cyclobutane. The previous one was cyclohexane. This is your cyclobutane, right? So once again, imagine that you are visualizing from here. You see a bold line once again. Methyl is on the top, hydrogen is on the bottom. You draw a thin horizontal line because here you are visualizing from the front over here. So hydrogen is going to be on the left hand side. This methyl is going to be on the right hand side. Okay. So 1, 2, and 3. All right, you have R configuration over here. Okay, so this is how easy it is, guys. All of the four important systems I have told you: the alkylidene cycloalkanes, two types of Spiro nomenclature, then third is your biphenyl system, and fourth is your alene system, right? So all of these are very, very important and very similar to answer. They are very scoring, and always you get a question in your exam about the nomenclature, right? So more short trick video coming up on stereochemistry. Please like the channel, and also like and share the videos, also subscribe, and hope you are watching all the important playlists that I have made for all of you, right, for organic chemistry. Please do watch and share. Thank you so much. I'll see you in the next video.